Hello, this is clip number 2 looking at momentum at GCSE AQA for higher tier, triple science. Last lesson we looked at if you have an object of a mass 2 kilogram and the velocity of the object is going to be 3 meters per second. What we looked at last lesson was the momentum can be calculated by mass times the velocity. So what we're saying here is that if we have an object with a certain mass and a velocity, the object is going to have this thing called momentum. And we can calculate the momentum by doing 2, which is the mass, 2 kilogram, times by the velocity, which is 3 meters per second. And the answer is going to be 6 kilogram meters per second. What I've done here, I've deliberately put down this unit here, 6 kilogram / meter second. This is totally wrong. The units for momentum is kilograms meters per second. Now, this is quite a straightforward example, but now what we're going to look at is that supposing if the object, this mass, actually collides into another object, how would we then how would we use the physics, how would we use momentum in order to calculate what happens after the collision? Well, to look at that, we actually look at this situation here right now, where we have the mass of the object is 2 kilogram now, and the velocity of the object is 3 meters per second. Now, we also know that this is going to collide into another object, which is actually a rest point. It's not moving at all, but it has got a mass of 2 kilogram. So this situation is going to be before collision, basically. Now, what happens after collision can be seen by here, that we are now going to assume that the first mass, which is 2 kilogram, is actually going to move at 2 meters per second. So we've actually set this as 2 meters per second. The object is actually going to move at 2 meters per second. If that is the case, we need to determine what happens to this mass here, and this can be shown by this mass here. We've actually labelled this as a velocity v, obviously the same mass again as 2 kilogram. Now, in order to do this calculation, we need to apply conservation of momentum. And what conservation of momentum is that the momentum before the collision, is always going to be equal to the momentum after collision. Okay, so what we're saying here is, if you calculate the momentum of this mass here, and obviously calculate the momentum of this mass here, which is 0, then we can write this as 2 times the 3, and then add 2 times 0, and this is the momentum before, is going to be equal to the momentum after, which is going to be 2 times 2 plus 2 times v. So what we're really saying is that the conservation of momentum is a law that specifies that the sum of the momentum before collision is equal to the sum of the momentum after collision. What I mean by sum, I mean working at the momentum of, let's say, this mass here, and working out the momentum of this mass here and adding them up together. This is going to be equal to the momentum of this mass again here, and the momentum of this mass here again, and adding them up together. And what you'll find is that when you calculate this, this is actually obviously going to be equal to 0. This is going to be equal to 6, and as a result we're going to have 4 plus 2v. When you do your maths correct, obviously we'll work out v is equal to 6 minus 4 divided by 2, and the answer is going to be 1 meters per second. This is how we actually then use momentum in order to calculate the velocity of an object after collision. So let's just make sure what we have understood so far is that if you have a situation taking place where 2 objects striking into each other, like A striking into B, we're going to have a situation after collision where we are going to assume that the mass of this object is 2 still, but also it's going to have a velocity of 2 meters per second. We don't know the velocity of this object here, but we need to calculate it. So to do that, we have to work out the momentum of this, work out the momentum of this one. You add them together. This is equal to the momentum of this one, as you can see, plus the momentum of this one, which is 2 times v. And when you set the maths right, we're going to get 2 times v is 6. Obviously add the 0, which is 6, equals 4 plus 2v. And by doing the calculation here, we can see that v is equal to 6 minus the 4 divided by 2, and the answer is 1 meters per second. And this is how we apply conservation of momentum in order to calculate the velocity of an object after collision. Next lesson, we will be looking at more examples based on conservation of momentum and how we can calculate further calculations based around this question.